The next algebraic operation what we have is difference. Okay, so here we are looking at difference between the two matrices. Okay, or difference of matrices you can also call it. Suppose again you have matrix A which is given by Aij m cross n, order is m cross n, and you have matrix B which is Bij m cross n. Okay. Now what we are looking at? We are looking at A minus B. Okay, so we are looking at A minus B. So here we do each and every element you subtract. Just like addition, there is no difference at all. Just like addition, you subtract each and every element of the two corresponding matrices. So here also if you think about it, don't you think the order of the matrix is very important? M cross n and m cross n. So if the order is different, obviously you won't be able to subtract. That's why we have to have the same order for the two matrices. And along with that, the important part here is the values whatever you are going to get. The most important part is the order of the two matrices should be the same. Okay. Now let's take an example in this one. So again here A minus B, this is going to be Aij minus Bij with a order of m cross n. Let's take a very simple example and try this one. Suppose say matrix A is equal to, we'll take a different type of matrix. Say 5, 1, 3. Now this is 1 cross 3. It's a row matrix, correct? Say matrix B is equal to, this also should be a row matrix. Say 2, 5, 1. Okay. Now A minus B is equal to 5 minus 2. Next 1 minus 5. Then 3 minus 1. So A minus B is equal to 3 minus 4, 2. This is going to be a 1 cross 3 matrix. Fair enough? This is how you do difference of two matrices. Now again we have 4 properties here. Let's look at the 4 properties. The first one is commutative. So in commutative, it's quite obvious that the matrix difference of matrices is not commutative. In the sense A minus B is not equal to B minus A. It is not commutative. Then associative law. If you have 3 matrices A, B and C, then A minus of B minus C, and the next one is A minus B of minus C. So here whenever we talk about associative law, this also need not be equal. Okay, need not be equal. Next is you have identity. That means there exists an identity, but here A minus 0 is equal to A. This is true. Okay, but like additive identity, you cannot do commutative part of it. Okay, so that is not true at all. Fine. Next is you have inverse part. See, inverse is what you're going to have some matrix A. Okay, and when you subtract it with the inverse, you should get the identity. But see, whenever we talk about identity element or identity matrix, especially for subtraction, we generally consider that there is no identity for subtraction. To be very, very honest with you, this is not the way how subtraction works. Okay, because 0 minus A and A minus 0 are not one and the same. That's why we do not consider it that way. Fair enough? See here, even for inverse also, let me just write it the way how we used to do for addition. You have A minus of A is equal to 0. Okay, A minus of A is equal to 0. That means in the sense you have to take the matrix and then you have to subtract by itself to get 0. Okay, but all the 4 properties you are seeing right now, commutative, associative, all these things, the most popular one what they will ask you is the commutative one. Okay, no one is going to ask you prove that there is no identity element for or identity matrix for subtraction. Prove that there is an inverse for subtraction. These are not the types of questions because mathematically speaking that particular law or that particular property is not valid or it doesn't make any sense. Clear? So the properties what you're seeing right now, it is given to you so that you understand what are the similarities and differences between addition of matrices and difference of matrices. Fair enough? So anyway, these 4 laws, these are not as important as what we studied for addition of matrices, the properties of addition. Whereas the normal subtraction and the commutative law, these 2 are quite important. Fair enough? Now in the next video, we'll do few more properties on multiplication and you will understand what and how to do multiplication of 2 matrices.